Welcome to Physics in Minutes, and today we're going to talk about unit conversions made easy. If you've never done it before, you might think it's very difficult, but it's actually really simple. You don't need to know much of anything more than you already do. The method I'm explaining is very similar to simplifying fractions. Now, before you freak out and think how much you hate fractions, let me give you a very easy example. Consider the fraction 2 over 4. Now, most of you probably know instinctively that that is equivalent to 1/2. But how did you come to that conclusion? It's really simple. You can rewrite 2 over 4 as 2 divided by 2 times 2. And you can simplify that fraction. Because there's a 2 in the numerator and in the denominator, you can cancel both of those. And if you do, that leaves you with just 1/2. That is the idea of how you simplify fractions. In unit conversions, we do the same thing, but instead of canceling out the numbers, we cancel out the units. Here's what I mean. As a simple example, let's look at this car and suppose it's going 15 meters per second. If you live in the United States, you probably have no idea what that means. 15 meters per second, is that fast? Is it slow? How does it compare to miles per hour? So what we're going to do here is convert from 15 meters per second to miles per hour to see how fast this car is actually going. Before we do that, I do want to point out one thing that just to make sure you understand. When you say meters per second or miles per hour, what you're saying is the fraction. It means that the measurement of distance, which in this case is meter, is on top. And the measurement of time, which is the second, is on bottom. Let's start with the units of time because it's something we probably understand a little bit better. So we know eventually we need to get to meters per hour after just changing the time from seconds to hours. To do that, we need to set up a couple of different fractions. First, since seconds are in the denominator here, we need to set up a fraction with seconds in the numerator, just like this. That way, these seconds will cancel with the seconds here. And we go from seconds to minutes because that just makes sense. You go from a smaller unit to a larger unit, and then eventually we'll go to hours. But since we have minute in the denominator here, we need to get rid of that, meaning the next fraction needs to have minutes in the numerator, so we can do the exact same thing. And as we already know, we will be converting eventually to hours. So hours will be at the very end in the denominator. That way, as you can see here, all of our units of time had canceled besides the hours. So that's the only thing that's going to be left. Now that we have the general idea set up, all we have to do is put in the numbers. And that is generally the easiest part, to be honest. All you have to do is if you look at this fraction here, we need to write that fraction in such a way that it's equivalent to 1. I don't mean that the number is 1, but that the idea or the concept is. And it's actually a lot easier than it sounds. For example, let's just take 1 minute. We know that 1 minute is the equivalent to 60 seconds. So if we have 1 minute in the denominator, we must have 60 seconds in the numerator. And that's really it, which tells us that the next step is almost the exact same. 1 hour is the equivalent to 60 minutes. So all we have to do is 60 minutes in the numerator, 1 hour in the denominator. Now that we have all of this set up, and once again we can tell that all of our units are canceling besides meters an hour, all you do is multiply all of these things together, which you should probably do with a calculator because I don't think you can do that in your head. And if you do, you end up with 54,000 meters per hour, which I don't know about you, but it seems like it's going really, really fast right now. However, we still don't have it in miles per hour, so we don't really have a good baseline yet. We're now going to do the exact same thing, but instead of converting the time, we're now going to convert the distance. And the reason I broke it up into 2 is simply because I didn't have that much space here. You can do it all in 1, but I broke it up because I think it makes it a little bit easier as well. Now, moving on to the distance part, we need to know how many meters are in a mile. And this is something you can just look up. It's technically 1,609, but I'm just going to round it down because it doesn't really matter that much here. So we'll go with 1,600 meters per 1 mile. Now, all we have to do is the exact same method. We know that we have meters on top right here, which means that we're going to have to create a fraction where meters are on the bottom and miles have to be on top. We just plug in the numbers we already know, where we have that 1 mile is the equivalent of 1,600 meters. Once you've done that, again, all you do is multiply this number by this fraction here. In this case, you end up dividing them, and you end up with 33.75 miles per hour. So as you can see, 15 meters per second is not really all that fast. So it's faster than you're going to be going in the school zone, but quite a bit slower than the freeway. And that is the beauty of unit conversion. And I know that it sucks when you get something you have no idea what it means, but being able to convert it from something you don't understand to something you inherently already understand is actually really useful. For example, if I give you the temperature in Celsius, if you live in the United States, you probably have no idea what that means. But you could convert that to Fahrenheit, and then you do have an idea. And that is it for unit conversions made easy. If you have any comments, questions, or concerns, go ahead and let me know down in the comment section below. And if you're taking a physics class or you just want to learn more about physics in general, be sure to like and subscribe to my channel because I'm going to be trying to follow as best as I can the way that courses are normally going this semester. So if you're in a physics class and you get stuck, go ahead and look me up and I'll probably be working on the same thing that you are. Thank you for watching, and I'll see you next time.